In this video, we're going to start looking at our fundamental counting principle. However, before we do that, we're going to first talk about the factorial. Right? And so what is the factorial? So for any counting number n, the factorial of n, which is denoted with this n followed by an exclamation point, it is n factorial is equal to, we multiply from n all the way down to 1. So n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. All right, so that's what our factorial is. In general, at least, for 0, we define that to be 1. It's defined separately from the formula above. But for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, any counting number, n factorial, you're multiplying from that number all the way down to 1. Right, so let's go through some examples. So if we were to evaluate 5 factorial, that's 5 times 4 times 3 times 2 times 1. And if we multiply those out, we get 120. Excellent. If we have 8 factorial divided by 4 factorial, 8 factorial, that means we're multiplying from 8 all the way down to 1. 4 factorial means we're multiplying from 4 all the way down to 1. And so, in this problem, we have a lot of nice cancellation that happens. That 4 and that 4 cancels, the 3 and the 3, 2 and the 2, and the 1 and the 1. So what we're left with on top is just 8 times 7 times 6 times 5. And if we multiply those out, we have 1680. If we go through the same general process with 20 factorial divided by 10 factorial times 10 factorial, 20 factorial is 20 times 19 times 18 times 17 times 16 times 15 times 14, 13, 12, 11, and then 10 all the way to the end is just 10 factorial. And on bottom, we have a 10 factorial, so 10 times 9 times 8 times 7 times 6 times 5 times 4, 3 times 2 times 1, and then we have a second 10 factorial, right? So we had 10 factorials on bottom. One of those will cancel with this. The other, we can do lots of piecewise cancellation. So 10 goes into 20 2 times. 9 goes into 18 2 times. 8 goes into 16 2 times. 7 goes into 14 2 times. 6 goes into 12 2 times. 5 goes, 5 times 3 is 15, so 5 and 3 cancel with that 15. 4, a 2 times a 2 will give us 4. And this 2 and this 2 would cancel. And so, what are we left with on top? On top, we are left with a 2 times 19 times 2 times 17 times 11, right? So times 1 times 11. And when we multiply all that business out, we get 184,000 756. Excellent. We can also do something like this. N factorial divided by r factorial times n minus r factorial, where n is 28 and r is 15. So this problem is really just saying 28 factorial divided by 15 factorial times 28 minus 15 factorial. Now, a factorial cannot be distributed, so we can't call that on bottom a 28 factorial and minus a 15 factorial. We have to do the subtraction in that parenthesis first. And so as we do that subtraction in that parenthesis, we have a 15 factorial. 28 minus 15 is 13 factorial. On top, we still have our 28 factorial. We can expand 28 factorial. That's 28 times 27 times 26 times 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, and then we have 15 all the way down to 1, which is 15 factorial. We had a 15 factorial on bottom, which is why I did not expand that on top, because those will just cancel right away. And then we have 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so now we can start doing some cancellation. 15 factorial cancels there. This 13 doesn't go into anything nicely, but 13 times 2 is 26. The 12 goes into 24 2 times. 11 goes into 22 2 times. 10 goes into 20 2 times. 9 goes into 18 2 times. 8 goes into 16 2 times. Then we have this 7 to deal with. 7 goes into 21 3 times. 6, oh, what does 6 go into? Well, we could group together a 2 times 3 is 6, and so that will cancel. 5 goes into 25 5 times. 4, we can group together 2 2s and cancel them with a 4. And then we have a 3. Oh, where would we have 3? 3 goes into 27 9 times. So if we multiply the stuff left on top out, we have a 28 times 9 times 5 times 2 times 23 times 2. And when we multiply all that out, we have 112,326,480. That is factorials. So in our next video, we will look at the actual fundamental counting principle.